For today's lesson, we're going to be talking more about complex numbers. So complex numbers are 5 minus 7i, something with a real part, something with an imaginary part. Did you know that you can graph complex numbers? Probably not. We haven't ever done it before. And once we graph it, we can also talk about the polar form of the complex number. And then once we know that we have both rectangular and polar forms of complex numbers, we can figure out what it is we have to do to convert back and forth between them. So starting with, how do we graph them? Would you agree those are a couple of examples of complex numbers? We're going to graph these just like we do with vectors. This is going to look almost the same. The steps are going to be basically the very same as what we've done with vectors, so the math is going to be very familiar to us. The difference is we don't have an I hat and a j hat. We have a real and an imaginary part. So our axes are not I hat and j hat. Our axes have to be real and imaginary. So for the red 4 plus 3i, I am going to go 4 in the positive direction on the real axis, and I am going to go 3 in the positive direction on the imaginary axis, and wherever those line up, that is my 4 plus 3i. So given that and given everything you've done previously, Callum, what quadrant will my blue one be in? It's going to be over here for negative 2 minus 6i. It'll be in the third quadrant for minus 2 minus 6i. So I'm going to go 2 in the negative direction on the real axis, and I am going to go 6 in the negative direction on the imaginary axis. Looks like about there. So that is my minus 2 minus 6i when I have graphed that imaginary number. Since this is so similar to what we've done with vectors, let's compare side to side. So I've drawn 30 degrees in both pictures, and it's 4 units long, and my sides of the triangle are 2 and 2 root 3 in them. Notice with a vector, the axes are I hat and j hat. With complex, it's real and I. Don't let yourself get confused. I hat is vector. I is imaginary number. When it is complex numbers, I is vertical. When it is vectors, I hat is horizontal. So be careful with that. So if we wanted to do this one as a vector, it would be 2 root 3 I hat plus 2 j hat. And this one, from what we just talked about on the previous slide, would be 2 root 3 plus 2i. Let's talk about polar form for vector first. Don't worry about what we've just written down in rectangular form. Let's go back, just look at the picture. If you have this picture, can you look at the picture and tell me what the polar form of that vector is? Evan? At, the little sled symbol, we read it as at. Perfect. We know that that one is 4 at 30 degrees. This one is also 4 and 30 degrees, right? But we do not use the little sled symbol when we are doing complex numbers. We still have the magnitude of 4. And what we use instead is going to look and seem very, very weird. What the heck is that until I explain it? It is going to be the 3 letters CIS, which we read as cis. So exactly the same, except sled for the vector, cis for imaginary. And to make that not seem quite so bizarre, cis simply means cosine of the angle, the C is for cosine, plus I is for imaginary, times the sine, S is for the sine, of 30 degrees. The 4 out in front then means that we would distribute that 4, and we would have 4 cosine 30 degrees plus 4, and normally we put the I at the end, right? So 4 times the sine of 30 degrees for the imaginary part. The number out in front is still the magnitude, the absolute value, how long is it, and then we still have the angle in there. Let's make sure that this really does mean the same thing as 2 root 3 plus 2i. So what is the cosine of 30 degrees? You guys better know that from your unit circle. Come on, what's cosine 30 degrees, everybody? Root 3 over 2, so we have 4 times root 3 over 2. What's the sine of 30 degrees? So 4 times root 3 over 2 becomes 2 root 3 plus 4 times a half becomes plus 2 times I. So it does give us the very same thing. So this isn't that bad. It is also very much like what you have done with vectors. When you got the horizontal part, didn't you say that I hat is 4 cosine 30 degrees, or r cosine the angle? And the vertical part is r times the sine of the angle? So that is exactly what we are doing with this. So now that we know that, let's see if we can convert back and forth between these, and it's going to be the very same process as with vectors. So 3 plus 4i, first thing we want to do is just a quick sketch so we know what quadrants it is in, so we know if we're going to end up having to add or subtract with 180 or 360. So everybody, what quadrant? First, so this one's going to be real easy. So 3, 4, and how big will r be for this one? What? How do I get r? Been doing it a long time. Don't make it hard. Pythagorean theorem. Okay, if it weren't as easy as this one, we'd do the same thing that we did with the square root of I hat squared plus j hat squared, except here it would be 3 squared plus 4 squared. But what does that equal, and what would have been the easier way to do it from the very beginning? Square root of 9 plus 16 is the square root of 25, which is 5. But when you have 3 and 4, what do you know about the hypotenuse? So for this one, you could have just said a triple. Most of them you are going to have to do this way with the square root of the horizontal squared plus the vertical squared. So that means polar form is going to have a 5 out in front of cis. Not the sled, but cis. So now how are we going to get this angle that we need right here? How do we get rho when we are doing vectors? Or looking at the picture, what will we do to get rho? Skylar? Tangent, is that what I'm going to actually use on the calculator, is tangent? Tan inverse is what I'm going to need because I want to get the angle. And so for this one, the tangent of rho is opposite over adjacent 4 over 3, or my angle is the inverse tan of 4 over 3. Since I'm in first quadrant, am I really going to use that angle, or do I need to change it? So that's going to also be theta. And I haven't memorized 4/3 on my tangent unit circle, so I need your help on your calculators. How big is that angle? When we were doing vectors, it was inverse tan of j hat over I hat of the vertical over the horizontal. It is still the inverse tangent of the vertical over the horizontal. Morgan, what you get? And that's all there is to converting that to polar. Questions? Then let's go the other way. Let's start with cis, let's start with polar, and go back to the other one. Sometimes they will say in the form a plus bi, sometimes they will simply say convert it to rectangular form. So 7 cis 43, first quadrant just a little bit lower than the 45-degree angle. And this is my real This is my imaginary. So how do I find A? Billy, how am I going to get A? Okay, perfect. That is going to be 7 cosine 43 degrees. And you can do that two ways. You can figure that out two ways. You can look at the picture and say the cosine of 43 is adjacent over hypotenuse, so A over 7, so A is 7 cosine 43. Or you can expand this out because we said cis means cosine of the angle plus I times the sine of the angle, and distribute the 7. So if we're just distributing the 7 on that, we have 7 cosine 43 plus 7 sine 43 times I. You do not add 7 cosine 43 plus 7 sine 43. They are two separate things. You're trying to get the real number, and then you're trying to get the imaginary number. So I need you guys to enter those on your calculators for me. 7 cosine 43 and an answer, 7 sine 43 and an answer, and then you'll help me know what it is that I need to write down. And be sure you're in degrees after some of yesterday's homework assignments. Ava, you have the cosine one? And who's got the sine? Hope? And just be sure you don't forget I, or you've blown the whole answer. Does this seem familiar to what you were doing with I hat and J hat? For the horizontal I hat, is it equal to 7 times the cosine of, or R times the cosine of the angle? Just like we did here. For the vertical part, the J hat, didn't you do R times the sine of the angle? Very same thing. I'm going to do another one that has these same directions. It's going to start off with cis and say convert it. But now I want an exact answer, so no calculators. So the easiest way to do this is, what does cis mean? Cosine plus I times the sine. Let's expand it out. So 6 cosine 135 degrees plus 6 sine 135 degrees, just like it is. We don't have to worry about coming up with an acute value or anything for that. Do we know the cosine and the sine for 135 degrees? Sydney, what's the cosine of 135 degrees? If this is my 45 degree angle, what's that x value going to be when I'm right smack in the middle of the second quadrant? Positive or negative? Negative root 2 over 2. And what about the sine of 135 degrees? What is that going to be, Gavin? I am still right here in the middle of the second quadrant. What is the sine when I'm there? A half's down here. It's this middle one. Positive root 2 over 2. And then I've got to have the I in there. Oops, that's what I'm saying. Always proofread these. You see how it's easy for me to leave out the I, but haven't missed any for the final answers yet, and you guys aren't going to let me. Then if we multiply, negative 3 root 2 plus 3 root 2 times I. So far we haven't really done anything that's any different math as far as the calculations than we've done before. Now we're going to multiply complex numbers. You've done that before with the rectangular form, right? You can take 3 plus 4i times 7 minus 2i, FOIL. You get a real number, you get something with I that you combine. The last one has an I squared. Change the I squared to a negative 1. You've got a real number. Put that together with the first and you're done. And that's one way that you can always multiply complex numbers. If you have it as two polar numbers, polar form, you can convert those both to rectangular and then multiply this way. Or, now my AB down here is going to have nothing to do with the A and the B we just had. If you have two complex numbers that are in polar form, you can leave them in polar form, and all you have to do to multiply them times each other is to multiply the magnitudes, the numbers out in front. For the angles, you add them together. To prove this, it's going to involve a little more trig than we've learned yet. Maybe by the end of the semester we'll have enough that we could go back and actually prove or derive this. But for now, I want you just to take my word for it. Just like when you have problems with fractions, you have to simplify before you're done. You do have to simplify this angle. If it is a negative angle, convert it to what would it have been if you'd gone in the positive direction. If it is going around the unit circle more than once, convert it so what would it be if you were just going around one time? And to be very specific, 0 is less than or equal to the final angle that you end up with, and that is less than 360. It is much simpler to say, stay right where you are, than go all the way around a big circle and end up where you started. So the simplest form is just stay put. So 0 is simpler than 360 degrees for those. And we'll do a couple more examples where we practice using this. Now, if you have them in polar form, or actually if you have it in rectangular form, something plus something I times something I, you can distribute FOIL like you've always done. You could convert them both to polar and do it this way. If you have it in polar form, you also have two choices. Do it this way, or convert it back to rectangular and do it the old way. And depending on the problem and what you're doing, you might decide one way is easier than another. Looks like everybody has this copied down, so let's try a couple of examples. So remind me, what do I need to do with the numbers out in front? Everybody, what do I do? Multiply those two. So I'm going to have 4 times 2 root 2. And then what do I do with my angles, everybody? So I need to add my angles. So I'm going to have 275 plus 135. And let's see, 8 root 2. And if we add 5 and 5 is 10, 10 and 1 is 11. 410 degrees? Is that okay for my final? No, because I'm going around the unit circle more than once. So, Jen, would you convert it for me? 410 is the same as how many degrees? And how do you get 50 degrees? So we're going to subtract 360, subtract the first time around the circle, 8 root 2 is 50, and this one just said final answer in polar form, so we're finished. Questions there? One last example, and then I'll have a few that I will have you guys do just for some extra practice. Multiply these, but this time back to rectangular form, and exact means no calculator. I can do this. Come on, it's the last one. So what do I do with the numbers out in front? Multiply. What do I get if I multiply those? Giselle, what do I get if I multiply those two numbers? What's 2 times 3? Okay, what do I do with my angles, everybody? And what do I get, everyone? Okay, how do I go from polar to rectangular? I just write out the cosine and the sine. I write out what cis means. So negative 6 root 6 cosine 90 plus negative 6, so just minus 6 root 6 sine 90 times I. Do we know what cosine and sine of 90 are? Top of the unit circle, what's the cosine? 0 on the sine. So final answer, negative 6 root 6 I. So we've done a lot, but it really hasn't been that hard because it's mostly been stuff that you have already done before. Just to make sure that we get all of